because I find it quite fun. It's very precious, not on the part of the money, but on the part on creating it. So we are starting the chapter on volume. This is the introductory page on your textbook. In your textbook, it shares with you what you perhaps have learned before in your entire life before primary 5 about volume and capacity. These two words. So these two words, you may have encountered them when you're in primary 1, 2, science, and these ideas. So these are some of the vocabulary terms that you have seen. From primary 2, you have learned this term called the cube. Some of us may be very familiar with the cube because you play Rubik's Cube. So you can take out one of your cube now and study it. But I'm fine with you making marks on the cube. Is yours now. Huh? Yeah. And so this is the cube. And then there's this term that you should have learned when you're primary 2. It's called a cuboid. It looks like this, like a tissue box. This tissue box here is made out of 6 rectangular faces or 4 rectangular and 2 square faces. So you take out a tissue box, or you look at my food tray, or you look at my tank here, this fish tank that I built. It has rectangular faces all around it. It's a tank because it doesn't have a cover, but the top is still a rectangular face. So you look at even your textbook book here is a cuboid. They can count 1, 2, 3, 4, 5, and 6. 6 faces. But it's quite a flat cuboid. But mine is a cuboid too. So these are the 2 keywords. Then there's this thing about volume that you have heard when you're in primary 2 or in science. So in science, you perhaps have learned this term solid, liquid, gas. Very good. So you know that these things take up space because they are matter. So when you talk about volume in terms of liquid, it refers to the amount of liquid inside a container. So the volume of a liquid in a container can be measured with these units called liters or milliliters. How is the term volume different from capacity? It's written here. Capacity is when you, what kind of limit? Yes, Shami? All the way when it's full, like your backpack. How much can you, like, how is this your backpack? How many things you can fill until it's like full and full? Anything more will overflow. So capacity is talking about when it's full. So like, for example, you see this beaker here. Is it full? Is it to the brim? No. So this beaker here is, the liquid inside is not all the way to its capacity. It's not filled all the way to the brim. There's some liquid inside. The volume of the liquid in the container is actually 1 liter. But actually, the container can fill up more than 1 liter. See, there's some space here, right? I can continue to fill it. Now, then how is this got to do with the cube and cuboids? Comes to the next question. Previously, when we learned area, just before this chapter, area of triangle, you get back to the textbook, the recall page of area of squares and rectangles. You look at this square here, Can you see? This square is a flat square. It has two dimensions. What do you know what two dimensions mean? 2D. You know 2D, right? Like a square. So why is a two Mickey Mouse as a sticker will be two-dimensional? Okay, but a real life Mickey Mouse is a mascot. Yeah, like animatronic, it will be 3D. Okay, like a mascot walking out will be 3D. But if it's a flat sticker, it's 2D. So you look at this square here. This is a square. This square here is a two-dimensional object. Okay, what are the two dimensions? Is length and breadth. In this case, is the same. So when it comes to, so as the rectangle here, it's a two-dimensional object, rectangle. It's two-dimensional because it has two measurements that you can say. Two dimensions. One is the length, one is the breadth. Two dimensions. When I multiply these two dimensions together, what do I get? I get the area, the space that's inside. Can you understand that? That means I can draw in little squares inside. I'm like counting squares. Does it sound familiar? So when we talked about the area of triangle after that, we were talking about the space that's inside the triangle. Can you understand, right? Such that when I come to the triangle, like this, I can count the squares inside, or I can use the formula half times space times height, because it's a two-dimensional shape. Now, come to this cube. It's now called a 3D object. Why is it called 3D? Yes. So the cube is now 3-dimensional. It's a 3D. It has length, it has breadth, and now, yes, a new thing called the height. Or you can also call the depth. How deep is the swimming pool? The swimming pool is rectangular. And I add in, okay, the rectangular depth. I will talk about how deep the swimming pool is. So the interesting thing about this is that when I take the length times the breadth times the height, or length times the breadth times the how deep the pool is, I actually get the volume. That's correct. Okay? Yeah, which in this case, okay, which in this case will give you, look at here, 3 measurements. So my highlighting comes in again. I get a length, a breadth, and then a height. 3 dimensions. These 3 measurements for a 3-dimensional object. So the volume of the unit cube is the amount of space inside the cubes. So I could call this as a cube that is, you made it already? Skylar made it already. Yeah. That I made it with 8 cubes. And don't mix up about yours with mine. I have my own one. Yeah, very good, very good, very good. Yes, okay. Yes, of course. You can write it here in the book. That space. Are you able to make this? Is it difficult? No, right? One of the easiest things to make. And you realize that is a 2 by 2 by 2 cube. The length is 2 units. The height is 2 units. And the breadth is 2 units. And you realize that you can multiply them together to get 8 units cube. So area, you have centimeter times centimeter give you square centimeter. So now you have unit times unit times unit give you cubic units. Okay. Now, we'll talk about this length, breadth, and height even more in tomorrow's lesson. We move on first. Move on to the interesting structures. Have you already built these structures? You realize that I can find out the volume of these solids easily by counting number of cubes. Because 1 cube will be 1 unit cube in terms of volume. So 1 unit cube means in all sides is 1 unit. So if I use 5 cubes, all right, it'll be 5 unit cubes or 5 cubic units. You have already built all these, right? With the cubes. Then I move on already, okay? You have built this already. So what I gave you, so if you're okay, we move on already, yeah? What I gave you were exact 1 centimeter cubes. So if you put your ruler to it, if you take your ruler and measure, you'll realize that the cube I gave you are 1 cm cubes. All the square faces are all 1 centimeter. So this is a 1 centimeter cube. Okay, right now, I'm going to give you my new toy. That's very nice. I'm going to use it as an example tomorrow, okay? Okay. All right. Now I'm going to give you a new tool. Boys and girls, you realize that all this is on your textbook. Does it look 3D to you? Yeah, it looks 3D, but you look at it closely again. Is it 3D? Can you feel the cube popping out? No, right? It's not at all. These real things, this is 3D. You can feel it, rub it. This is 3D. Is this 3D? No, it's not. So the challenge is that you are looking at this flat thing and you have to imagine it's 3D. Now, I'm going to give you my new toy today that I made painstakingly with my hands and printer. Okay, this I made is a special 3-dimensional space. Okay, boys and girls. Now, look carefully. it opens up like this. Okay? All right? This is a three-dimensional space. Okay? It should stand like this. I'm going to take my phone up to see. Can you see? So you stand up like this. So for example, I'm going to make solid C. Okay? Solid C. Look at the lines carefully. Can you see the lines? Can you see the three lines here? Can you see the three lines that are colored? I want you to take this and build it on the new toy that I'm going to give you now. So for example here, this is my three-dimensional space. I'll put it as I see the three lines. So can you tell which one is the purple line? Can you see? And then I have a yellow line here. Okay? Can see or not? Okay. Then I put it on top. Can you see? Now, Mara, can you come here and help me? I need a hand. Okay, because I'm trying to do video recording at the same time, so it's difficult. I need more hands to hold. Can you hold the paper? That's the two sides. Okay, so from my three-dimensional space, can you see that it matches the textbook one? Look at your textbook. Which one is this? C. Okay, I want you to build the solids on this three-dimensional plane. Can you understand? Can you understand or not? Yes, okay. So leaders, can you come here? No. Every group, every table, the first person on the right, come here. Amarana. You can try. I can lend you mine first. You can try. Have you gotten it already? Cheryl, you have not come here for your tablet. Elena. Okay, so I folded the edges. Aiden, Your group is waiting for you. Elena, that's for you, Adrian and Zara. Thank you. Now, I want you to play with this. You might need some help. If it's difficult for you to work alone, get your partner to help you. Your group mates to help you. Okay? So I made this and cut it out like that. You can see that this is like a three-dimensional space. 1, 2, and 3. When you fold it up, it gives you the three-dimensional space. I want you to try to build the structures onto this three-dimensional space. If you find it difficult to do it yourself, get your friends to help you. You can work together. For example, I'm going to make B now. No, don't tape this up because we are going to use this tomorrow for a different reason. But if you want blue tag for you to tape it together temporarily, you can have it. Yes. Anybody else want a little bit of blue tag? Okay, sit down. That's everyone. Sit down. Can the first person of the class now come and help us? I'll give you a ball, you give it to your friends. Share it out with them. Yeah, first person of the row. Angel, you can come and help your friends. Okay. Now you only need to pinch a little bit of it. Yes. Okay, so what I will do is, now, I purposely didn't paste these two edges together because we are going to use this for our next. Now, I did not paste these two sides together because we are going to learn how to transform the 3D space into two-dimensional as well. So, Marianne, so you can use the blue tag to temporarily stick the two parts together, but you do not need to make them, but they are not meant to be glued together. Okay? Now, you can see I'm holding up like that. I only put the blue tag temporarily to stick up the sides. Okay? I didn't tape it together because we need to learn how to open it up tomorrow when we do the front view, back view study. Okay? That's the difficult part. So I'm temporarily putting the blue tag behind it like this. See? Okay? I'm just temporarily. I'm not sticking the cubes together. Why are we sticking the cubes together? You don't need to stick the cubes together. You just need to make your paper steady. Okay? Now, right. I'll say one last time. I put the blue tag behind the two sides temporarily, like this, so that it can stand on its own. Okay? Like this. Now, tomorrow, we'll be moving on with this. Today, boys and girls, you have an important task. All right? I want you to go back and try to build the shapes on this at the backing. You see, I highlighted the lines, right? So look and observe. This is purple. is yellow, and this is an orange line. The three-dimensional lines, it matches on the paper here. Can you understand this? Okay, so your activity, your homework today is still continue to build this. Okay, all right. Now, keep your tools properly. Do not lose them. 1 sentence, I don't have any extra. Okay, this is my only one.